So here it says an angle in radians. So we have our angle in radians. Remember, everything on the diploma is written for a reason. They don't put any extra words. You might be like, but "an" is an extra word. No, "an" isn't an extra word. It forms a complete sentence, okay? Don't go fighting me on weird stuff like that. "An" is needed, or this would be a wonky sentence. It would be a Mrs. Lepp written sentence, okay? So, in radians is important. Coterminal, what's the definition of coterminal, guys? It lands on the same terminal arm. Okay, so it's coterminal with it. So if it's in degrees, you can add or subtract and get yourself an answer. We agree? Okay, so we have 30 degrees. There's two ways you could do this. You could convert everything to degrees and compare them, which is about what I'm thinking everyone's going to do. Or you could convert the 30 degrees to radians and work in radians, which I'm thinking no one is going to choose. But that's just a random guess or knowledge that I see everyone do it that way. So we can convert it if we want. So negative 5 pi over 6 is negative what? In degrees. Yep. Negative 13 pi over 6. You should all be trying these out to convert because that's what you're going to need to be able to do. Okay, negative 13 pi over 6. Zach, what'd you have? 7 pi over 6. 25 pi over 6. How much? 750. Okay, so if we take 30 and we subtract 360, we get negative 330. No. Okay, then we go the other way. 30 and we add 360. What do we get? 390. So no. So it's going to be this one. But let's add another 360. 750. Okay. An angle theta in standard position is shown below, the best estimation. So these are all in radians, correct? This is pi over 2 radians. This is pi. Pi is 3.14159, blah, 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 blah. This is 3 pi over 2. What's 3 pi over 2 in decimal format? What's 3 pi divided by 2? Which one fits? Mary is given the diagram below showing an angle of rotation of 120 degrees. The arc length is 40. Remember, if you're going to use that formula, theta equals A over R, this theta needs to be in what? Radians. And it needs to be the actual theta of the arc. So if they gave me, say, this theta instead, which would be how much? How can I figure that out? So it would be 240. Had they gave me 240 here and the arc of 40, would I be able to use that formula? First off, it's in degrees, so no. But second off, I need the actual angle of the arc, right? And I don't have it, so I'd have to subtract from 360 to get it. Okay. So the radius of the circle is 19 centimeters. So we'd first have to convert the 120. So degrees to radians, pi on top. And so what do we get? Nope. 2 pi over 3. Okay. So R equals A divided by theta by rearranging it. So R equals arc length, which is 40, divided by 2 pi over 3. And what do you get? 19.09 centimeters. So, yay. An equivalent angle of rotation is 4 pi over 3. Is that true? What is 4 pi over 3? When you convert it? 240. And what's this one? 120. If the arc length on the circle increases to 80, then the central angle must be 240. Well, we can prove this. We know the radius now is 19. We agree? 0.0, etc. We agree? And our arc length is 80. So if we want to figure out theta, we go 80. A divided by r? Yeah. 19.0, da, 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 da. What is that? What? Radians, right? And then we have to convert it to degrees. Radians to degrees, pi on. So we multiply by 180 divided by pi. And we get 240. Mary can determine the radius of the circle by dividing the given angle by the arc length. Dividing the given angle by the arc length, is that true? No, it's the arc divided by the given angle. So the two statements that are true are 1 and 3. Now, did it say two statements that are correct respectively? No, so if you put, you'd be correct. Now, I don't chance it. I always put them in order anyways, but I guess you could rebel in this way. I always put 1 and 3, even if it doesn't say respectively. A circle with a radius r is indicated by the arc length 35 pi. The two central angles are a theta over 15 and 17 theta over 15. 17 theta? Oh my goodness, 17 pi over 15? Those are pi's. For the angle a pi over 15, the value of a is. What does a whole circle add up to? But it's in radians, guys. 2 pi. So we're going to go 2 pi, and we're going to subtract off 17 pi over 15, which is actually 30 pi over 15. Subtract 17 pi over 15, which is 13 pi over 15. So what's a? 13. Yeah? The next one says the length of the radius. I'm going to do it on the previous question, but the length of the radius, theta equals a over r. So r equals a over theta. The arc is 34 pi. And which is the actual angle that works with that arc? 17 pi. You need the angle that goes with the actual arc. We agree? So we don't need the new one we found. So they can give these two questions easily, no problem, because the two questions actually don't depend on each other, right? If you mess this one up, it has nothing to do with the next question. So they're independent of each other. 35 pi divided by 17 pi. What do you get? 30. Okay, this one. A point √3.5 and the point -√2 and 2 lie on the terminal arm of two different angles in center position on the circle. Angle theta were 0 theta, it's between 0 and pi, can be expressed in what? What is this angle? How much? 30. And how much is this angle? 135. How do we find the angle between them? 135 degrees minus 30 degrees, which is 105 degrees, which is great. However, it's not an answer. Multiplied by pi over 180. So 105 pi over 180 reduced is what? How much? 7 pi over. So the values of m and n respectively, 7 and 12. So your answer has to be 712. What if it was 127? You're wrong because it says respectively. If the point 0.2 and k lies on the a circle with the center at the origin. Center at the origin is the unit circle, right? Starts at 0, 0, and it has a radius of 1. So this is a fancy way of saying on the unit circle. And what did I tell you to do when it says on the unit circle? X squared plus y squared equals 1. They gave you an x, they want a 0.2 squared plus y squared equals 1. Y squared equals 1 minus 0.2 squared. When you take the square root, what are you going to... So we're going to get, yeah, y squared equals 0.96. Then you take the square root, which is plus or minus. So y would equal, do we have to work it down and then give the answer and then write that? No, they want it in plus or minus root b. So what's root b? So you always have to read the format of what they want, right? Because sometimes, a lot of the time, people just don't read properly and give me a wrong answer, even though they're correct in what they did. The terminal arm of theta, when it is drawn in standard position, so they're telling you to draw a terminal arm in standard position, contains the point xy where p is on the unit circle. If sine 0 equals 7 over 10 and tan theta is less than 0. So they're saying tan theta is less than 0. Tan's negative, so it's here or here. How do I narrow it down? This is tan negative. This is sine positive. Which one of those is sine positive? This one. I could care less about this one. Sign your resume. 7, 10. And then I'm going to put a negative here, because it's negative there. And they're going to have the answer to the positive version, which is wrong. So we're going to do x squared equals 10 squared minus 7 squared. X squared equals 100 minus 49. X squared equals, square root it, x equals, and the only reason why you get the negative is because you drew it, and by drawing it, you knew that x had to be negative. That's why I always say you have to draw. On the unit circle, point P lies on the terminal arm of angle theta in standard position. Okay, they want the 6 trig ratios. This is x, y. We agree? What's R? What's R? It's on the unit circle. 1. Okay, I was right. So R equals 1. So sine and cos are really easy. Why? Anything on the unit circle is? Oops. Calgary. Stampede, is it not? Boom. Cos theta is negative 5 over 13. Sine theta, 12 over 13. Really easy when it says it's on the unit circle. Your x is always cos. Your y is always sine. Yeah, I did. Mm-hmm. 100% did. And I podcast to prove it. Okay. So it's like I have something to go back on. So tan theta is going to be what? So it's going to be tan your x box. So 12 over 13 divided by negative 5 over 13, which is actually 12 over 13 times negative 13 over 5. Cancel. So it's negative 12 over 5. And the 3 others are really, really easy. Flip, flip, flip. Done. Secant theta is negative 13 over 5. You can flip answers. You cannot flip angles. Remember that? Cosecant theta is 13 over 12. And cotan theta is negative 5 over 12. What if I ask you for the angle? I give you this, and I say, what's theta? So in this case, I asked you for the trig ratios for theta. But I could have, instead of saying what are the exact values of theta, I could have said, determine angle theta. And why I put a question mark, I don't know, because it's a statement. Okay. Totally switches the question. Determine angle theta. Determine the trig ratios means give me the trig ratios, right? Angle theta, I want 60 degrees, 70 degrees, 100 degrees, 500 degrees, 300 degrees, blah, blah, blah. Okay? What did I give you? I gave you cos theta and I gave you sine theta immediately. Did I not? Anytime I give you a unit circle point, I actually gave you cos theta equal negative 5 over 13, or I gave you sine theta equals 12 over 13. We agree? So I can just theta equals cos neg 1 of negative or positive 5 over 13. Why positive? Because I want the reference angle. So second cos 5 divided by 13, which is 67.3 da 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 da. So that's my reference theta. Okay? So I know that it's cos negative. So it could be in quadrant 3 or 2. But what else do I actually know? It's sine positive. It's a point where the x is negative and the y is positive. Where is it? It's in quadrant 2 with a reference angle of 67 point something. So I'm going to go 180 minus that, and I get 112.6 degrees. That is actually what theta equals. Remember, every time, and that's what everyone forgets, when you're given a point off the unit circle, you're given cos and sine, and you're instantly given tan if you really want to, because you could do sine divided by cos, right? That's tan as well, y divided by x. You're given them all. So you can also solve for their theta. Okay? 10. Given that cosecant theta equals 8 over 5, super nice, they drew it. Probably not going to happen. This is a diploma question. Shockingly, they drew it. That's so nice of them. Probably not going to anymore. Cosecant is sine. So sign your resume. So this is resume your. And they were so nice and did it for you. And even put it in the right quadrant, knowing that x then is negative, right? So we're going to do x squared equals 8 squared minus 5 squared. X squared equals 64 minus 25. X squared equals 39 square root plus or minus root 39, but because of where it is, it's, and 39 is a prime number. Can't break it down. If you can break them down, reduce the radical, you have to, always. So if it's root 24, that's 2 root 6. You have to write it as a reduced radical. Exact value of tan. Tan your x box. So it's going to be 5 over negative root 39. You need to rationalize it. So you're going to get 5 root 39 over negative 39, or negative 5 root 39. It's the same as this, which is the same as this. All of these are the same. And so any of those can be given. Some people will be like, what if they give you both? They won't. They can't. They're both right. Okay? They'll give you one. Bless you. The exact value of sine negative pi over 6. and 7 pi over 4. So this is sine of negative 30 plus cos of what's 7 pi over 4? 315? Okay. Sine of negative 30 is the same as what? Sine of negative 30 is the same as what? Sine 330. Because we can just get their coterminals. Why can we use their coterminals? Because we're getting answers off of the terminating arm. So you can either say, hey, it's 330, or you can say, hey, negative 30 starts here, and it goes 30. Oh, that lands on the same arm as 330. Either way works. There's no more correct way, I guess I should say. So sine of 330, I go to 330, and I take the y, which is negative a half, plus cos of 315. I go to 315 and I take the x, which is root 2 over 2. They have common denominators, so it's negative 1 plus root 2 over 2, which is a. You're literally just pulling stuff off your unit circle. Tan theta equals 5 over 2, where 0 is less than or equal to 2 pi, then the largest positive value of x, or of theta. So, go back to the question. Do you see this? If tan theta equals 5 over 2, where it's between those, back I asked you for a trig ratio. I'd ask you for secant or cotan or tan or whatever. So you have to find the third side to give me a trig ratio, correct? Is this one asking me for a trig ratio? It's asking me for? So what do you have to do when you find theta? Reference theta, cast rule, give me answers every single time. When they ask for theta, reference theta, cast rule, give me answer. Reference theta, cast rule, give me answer, always. Okay? So reference theta is tan neg 1 of positive 5 over 2. Even if it wasn't positive, I would do positive. Okay? We're following? In radians, because it's not a nice decimal in degrees, I'm going to use radians. Reference theta equals 1.1902 ... radians. So I can round that to 1 decimal and carry on. That was a joke. You cannot round to 1 decimal and carry on. You have to keep everything to the very last step, then round. Okay, reference theta, first step. Second step, tan positive, right where it is. Tan positive is here and here. In this quadrant, your reference angle is the answer. Yes. Okay. In this quadrant, your reference angle is the answer. So like 1.2, because it says the nearest tenth. Correct. In this one, I have radians. This is pi. So instead of going 180 plus the degree, I'm going to go pi plus the radian. So pi plus my answer, 4.3 rads. And they want the largest one, so 4.3. Now I told you, when you have an equation, something equals something with one variable, you could punch it into your calculator and find out where they intersect, give me the x value. Could you not? So go to your y equals. You're going to go tan x in y1. We did this last year in grade 11 too. y1, you could do this for solving quadratics. y2, you can do this for solving anything where you have something equals something, one variable. Okay? So we are going to go tan x into y1, and we're going to go 5 over 2 into y2. Could we move the 5 over 2 and go tan theta minus 5 over 2 equals 0 and make this be y1 and 0 be y2? Absolutely. As long as you put one side then the other. Now, what I want to do is my answers need to be between 0 and 2 pi. So what am I going to make my x? My x min I'm going to make be 0, and my x max I'm going to make be 2 pi. My x scale, you could leave it to be whatever you want. I often do pi divided by 2. But if you want it to be 10, 7, don't let that X scale throw you off. Don't let you not be able to complete a question because you're completely confused to put for your X scale. It'll work no matter what you put. Okay, you just won't see really good ticks possibly, but oh well. My y min, I'm going to leave it be at -4. My y max be at 4, whatever. My 1y, so my tan is going to be drawn. My 1y equals here is at 5 divided by 2. So I'm going to have a horizontal line at 5/2, which is 2.5. So I'm going to need to at least be able to see where they intersect, correct? So I need my y max to be at least 2.5, or I'm not going to see that horizontal line at 2.5. We agree? If you have the calculator that doesn't change your, where's my calculator again? It left. One second. If you have a calculator that doesn't change colors, make your y2 thicker. Then you'll know for sure that you actually see two equations, right? Because if you say your y2 was 0, you wouldn't see it on your x-axis. It would just draw over top of it. So I have tan theta and 5/2. I'm going to go to my window. I'm going to make my x min 0, my x max 2 pi, because that is the restricted window. And then I'm going to make this be pi divided by 2 because I feel like it. My y min -4, and 1 works fine. Now, my window is in radian mode. So what does my calculator need to be in? Whatever your window's in, your calculator needs to be in. Ooh, here's my two solutions that I just got. They want the largest positive one. So that one. If I don't restrict my window to 0 and 2 pi, I'm going to have way more answers than I need possible. Right? I need to restrict my window to be the domain that they gave me. I go second trace 5. Enter, enter, enter. 4.3, and I'm done. Okay? So if you're ever given an equation where you only have one variable missing, so in this case it was theta, you can check with your calculator. Okay, each of the trigonometric ratios listed below results in a value of 0 or undefined. We could literally punch these into our calculator. Bless you. But if we punch them into our calculator, our window or our mode has to be what? Radians, because we're typing it in. So we go mode radian. So I'm going to go tan of pi divided by 2. Oh, I get a domain error. What does that mean? It's undefined. Also, tan is y divided by x. At pi/2, y is 1 and x is 0. Undefined. So the value of the ratio is 0. The value of the ratio is undefined. So 2. 3 pi/2. Cotan. Cotan is x over y. And at -3 or at 3 pi/2, x is 0 and y is -1. So it's 0. If you don't know, hey, it's cotan is 3 pi/2. Oh my goodness, I don't remember how to type it in my calculator. Oh right, Lepp told me to look at the formula sheet. So I look at my formula sheet, it says cotan equals 1/10. Oh, boom, it tells me how to type it in my calculator. 1 divided by tan 3 pi divided by 2. Oh wait, is it tan? 1 divided by 10? No. I'm okay. It says undefined, but I. Okay, so it's x divided by y. Did I mess up? 0 and -1. Is it 0? Oh, see, this one you won't catch in your calculator. It'll tell you an error in your calculator. Why? Because tan of 3 pi/2 is actually undefined. So 1 divided by undefined is undefined. But if you do it this way, you're going to actually find out it's. No, it's 0. I'm just saying you can't just use your calculator. That was my point. Okay. Sine of theta. Go to theta, pick a y, which is 0. Thanks, guys. And then go to 2 pi, which is here. It's sine. So it's going to be 1 and 0. Sine is this. Cosecant is that flipped. Undefined. Yep. Pi over 6 is 30. 5 pi over 6 is 7 pi over 6 is, and 11 pi over 6 is. These angles in degrees respectively are 300, 150, 210, and 300. No. They are all part of the solution pi over 6 plus 2 pi n. No, if I do pi over 6 plus 2 pi, that's 30 plus 360, which is 390. It's not even on there. So no, that's not good. Sine 7 pi over 6. Sine 7 pi over 6. What's y at 7 pi over 6? You go to your unit circle. You guys are killing me here. Go to sine 7 pi over 6 and pull off the y. And cos at 5 pi over 6. Shh. They're both negative. Yes, they are. Cos is also negative in this quadrant. Sine is also negative in the third quadrant. So they are both negative. So it is statement 3. You have to fill in a unit circle. On your diploma, you don't even get a blank one. Note to self. 15. For the function y equals a cos theta plus d, the range is negative 4 to 10. What are the values of a and d? A is your, and d is your midline. So I'm going from negative 4 to 10. What is that a distance of? 14. 14 divided by 2 is? Amplitude is? Okay, then I count down 7. And I get to 3. I count up 7 and I get to? So what's my midline at? A function is represented by the equation y equals sine 3x. I see this instantly. I'm going to stop. And I'm going to write y equals sine 3x plus divided by. You have to remember to take that 3 out. Taking the 3 out is dividing by 3. The value of the phase shift is actually pi over 3. And the period, how do you find the period? 2 pi over b. And b in this case is 3. So let's see. So don't forget to take that b value out. Did I skip one? Or was that it? Oh, yeah. Given this one, we're going to look at next unit. We'll look at it next unit. We didn't look at tan. 2. Nope. I'm not taking the mark in. Sure. Bonus. I wanted a homework check. You could have found most of these online. Okay. The partial graph of the cosine function below has a minimum point at pi over 2 and negative 2, a maximum point at pi over 8. So they're telling you this so that you're not trying to guess. Is it close to this? They're telling you. Oh, pi and 8. And if you're like, well, then why did I do it? You have a test tomorrow. That's why you did the hand in. Shockingly, I don't know if that's good enough, but that is going to be good enough. All right. With a minimum possible phase shift, the values of A, B, C, and D respectively are. A is your amplitude, half the distance from your min to your max. So your min to your max is 10. So your amplitude is 5. Yeah, you're right. Thanks, guys. And then your B value comes from your period. So it's going to be 2 pi divided by, and it's pi because your x is in radians. So from max to max is pi. So it's 2 pi divided by pi. So it is 2. Your D is if you count up and count down your amplitude, they meet at the same spot. So if I count down 5, I get to 2. If I count up 5, no, I get to 3. If I count up 5, I get to 3. My midline is at, so my D is 3. They want the minimum possible phase shift. Now, this is the catch. It says A, B, C, D are an element of the W. The whole numbers. Whole numbers. Whole numbers start with the number that has a hole in it, not W. 0. 1 doesn't have a hole in it either. Start at 0 and work their way to positives. Okay? So they're indirectly telling you A has to be positive. If A has to be positive, we're looking for a positive cos. A positive cos, we look for the closest maximum. Where is the maximum? On it. What's my C? 0. Tricky, tricky. 5, 2, 0, 3. Which of the following statements are made? The true statements are, so we need true. The amplitude is 3. Amplitude is the absolute value of A. Yep, it's 3. The maximum value is D minus 3. How do we find the maximum value really quickly off an equation? D plus amplitude, and the min is D minus amplitude. So it would be D plus 3. So many of you do D plus A, and then you use the negative 3. That doesn't work. You have to understand it. The D is the midline. I go up the amount of amplitude, and I get to my maximum. I don't go up my amount of A, right? I go up my amplitude. So it's D plus 3, so this is wrong. The period is 2 pi. Period equals 2 pi divided by B when you're looking at an equation. On a graph, you just find it, right? So it's going to be 2 pi divided by pi, 2, and you get pi. Is the period 2 pi? No. When compared to the graph of negative 3 sine 2x plus d, so the only thing that changed here is the x and the x minus 5. Remember I told you, if you're going to say transformations between two graphs, you have to see what the original looked like. The original already had the 3. The original already had the 2. It had the negative 3. It had the d. The only thing that changed was the 5. So do I have to state the other transformations? No, because they didn't transform at all. The graph looked like that first. It's now just moved 5 to the right. And it does move 5 to the right because these actually were in brackets that I just kind of covered over with the green. So yes, 5 to the right. We're correct. If D is greater than 3, then the graph will have no x-intercepts. This graph right now is at a line of D, and it is down 3, and it is up 3. We agree? So, if D is greater than 3, let's make it be a value greater than 3. 4? Okay. If D is 4, let's say, what would my maximum be at? 4 plus 3, so 7. And what would my min be at? 4 minus 3, which is, my graph is from 1 to 7. Is there any x-intercepts? No. If it was 3.1, so we got closer, it would be 6.1 and 0.1. That's still above, right? So this one is true. So it's 1, 4, and 5. The height of a point on the Ferris wheel in meters above the ground is a function of time, and seconds can be represented by the sinusoidal function. The maximum height of the Ferris wheel above the ground, oh, it's a Ferris wheel, boom, boom, and it's a height of 1 meter above the ground. Shoo. Okay, so the maximum height of the Ferris wheel is 17 meters, so that's my y. The minimum height is 1 meter, so that's my y here. And we get 2 points down there. I'm going to get a point here and a point here. So how much is it between here and here? Because I'm really only making the equation of the circle, right? Not the base. 16 between here and here. So each of these is 8. That's my radius, which is a fancy word for my what? Amplitude. So I know my amplitude is 8. It says it makes 2 full rotations in 60 seconds. So how long does it take to rotate the whole thing? Once. 30 seconds. So we have 0 seconds and 30 seconds. Then how do we figure out the times in between? Divide by 4. So we get 7.5. So we get 7.5 here, 15, 22.5, and then 30. So we know we're right. What are the heights to get me here? Because I need the height of this actual coordinate. I'm listing these coordinates, correct? So what's the height of this coordinate? 9. There's a 1 here. The height of this coordinate? 9. Can we agree? Now it says, assuming that the particular point starts at the minimum height of the ground, write an equation for the height of the point on the Ferris wheel as a function of time in the form cos. So they didn't give us which a we had to do. They'll say a is greater than 0, a is less than 0. They didn't. So I'm going to give both. So we're going to have h equals positive 8 cos. What's my b? b equals 2 pi divided by 30. Pi over 15. Word problems are in radians. Remember that. Pi over 15. We'll figure that out in a second. T something. What's my midline? My midline is always this. The two numbers that are the same are my midline. It's where it cuts through the center of the Ferris wheel, or whatever wheel you're looking at, okay? Whatever circular object. So 9. I want positive cos, so I want the maximum. What is it horizontally? How long did it take me to get there? 15. So it's minus 15. It's how long? Remember, time is x, the height is y. So if I do the other way, h equals negative 8 cos pi over 15 t plus 9. Why do I have nothing added onto my t? Where did it start? At the minimum. When it's negative cos, I see how far away this is from the x-axis, or the y-axis, sorry. How far is it away from the y-axis? Nothing. Remember, this is negative positive sign, negative sign, because we're going up, down. The x values give you your c values very quickly. Determine a general solution for cotan x. So we get cotan squared theta equals 1. You have to solve for it. And you get cotan theta equals plus or minus the square root of 1. Remember, when you have a basic one like this, you're going to get solutions in all 4 quadrants. So you're going to get cotan theta equals plus or minus 1. Remember, tan theta equals plus or minus 1 at the 45s? Cotan's just flipped, so it's going to equal plus or minus 1 at the 45s. It's the same thing. If you take 1 and you flip it, it's 1. If you take negative 1 and you flip it, it's negative 1. So it's going to be here, 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 and here. So in degrees, this is 45. So it's 45. Our reference angle and degrees is the same in that quadrant. This is going to be 180 minus 45, so 135. be 180 plus 45, so 225. This can be 180 plus 45, or minus 360 minus 45, which is 315. 45 and 225 are 180 apart. 135 and 315 are 180 apart. The general solution stuff we're doing more of in next unit, but the general solution for this one in particular, we could go 45 plus 180 NEI, and I'll explain in a second why this isn't correct. It's close, but not correct. And then we go 135 plus 180 NEI, and it covers up all the solutions. Because these are 180 apart, and then these are 180 apart. Why isn't it completely correct? Not in radians. So it's actually pi over 4 plus pi n NEI. And 3 pi over 4 plus pi n NEI. Okay, this one, the wiper cleans off. The wiper on the rear window of a particular car moves through an angle of 5 pi over 6 in a single sweep and clears the region that's 16 inches wide, as shown. So it just clears this region here. The total perimeter, so they want all the way around it, correct? This is 16 here. This is 16 here. I now need this piece here. How can I get this arc? Theta equals A over R. Here's my radius. Here's my arc. Here's my angle that I have. So I need to find the arc. So theta equals A over R. So A equals R theta. So the radius is 4, and theta is 5 pi over 6. So it's going to be 20 pi over 6. Or, take a 2 out, 10 pi over 3. So this little green piece is 10 pi over 3 inches. I'm not reducing it yet because I don't want to round to my very last step. If you took it as a decimal, you'd have to keep the decimal. That's it. Then I need this piece here. How do I get this piece here? Well, here's my arc. Here's my radius. What's my radius actually? 20. And I have the same angle, correct? So A equals R theta again. The radius this time, though, is 20, and theta is still 5 pi over 6. So I'm going to get 100 pi over 6, or 50 pi over 3. So I'm going to go 50 pi over 3 plus 16 plus 10 pi over 3 plus 16. You get 95. A point A, x, y is the intersection point on the unit circle. So it's unit circle x squared plus y squared equals 1. Or unit circle, go to your unit circle. That's what it means. X squared plus y squared equals 1, or look at your unit circle. The coordinate of point A is. Now, this is also what people forget. On our unit circle, there are 3 things when they say on the unit circle. They say on the unit circle, that could mean x squared plus y squared equals 1. Where do we use that? When they give us an x or a y and want the other one. Okay? On the unit circle could mean that. It could mean go to your unit circle. Pull off answer. Okay? Or it could mean the coordinate is cos theta sine theta. And in this case, it means the third one. The coordinate is cos theta sine theta. They want cos of 145 degrees and sine of 145 degrees. That is actually the answer. It's not there. What did they do? Typed it into their calculator and put down the decimal. That's all they did. Cos of 145. Make sure you're in degree mode. I promise you some of these answers are probably if you're in rating. So, cos 145. Don't know what mode I'm in. It's not even, they didn't even put a rating mode one. Very nice. Cos 145. Negative 0.82. Sine 145. 0.57. We at the very least could have knocked these two out. Why? 145 is in quadrant 2, and x is negative and y is? At least we would have had a 50-50 if you were completely lost. You wouldn't be completely lost if you actually get to that. If you were halfway lost. Okay? Don't forget that. It says on the unit circle. Cosine, Calgary Stampede. Okay. London Eye observation wheel with a radius of 68. Radius means what? Fancy word for? Amplitude. Which is your A. Down to A and B. Didn't even get past the first sentence. Ride consists of one complete revolution, which takes 30 minutes. That's your period. So it's going to be 2 pi divided by 30, which is pi over 15, is my B, right? They both have pi over 15. We didn't reduce anything. Dang it. Okay, there's a platform of 2. There's a platform of 2, and I know the amplitude is how much? 68. I also know the radius is 68. I know that this height here is the same as my what? Midline. We agree? Oh my, why? Why are you in a morph suit? I'm recording. Good. This here is how much? 2. This here is how much? 68. How much did it take me to get to the middle? This one, and I don't even have to find C. I don't know. So I didn't even, the C didn't matter. What else could you have done? Try to make your window the same as theirs. Type them in and hope it looks the same. Last ditch effort. You can type in your calculator. An angle that's coterminal with the angle negative 11 pi over 4. What's negative 11 pi over 4 in degrees? Seven pi over 4 is what? 315. 5 pi over 4 is 225. 3 pi over 4 is 135. Pi over 4 is 45. Add 360. Negative 495 plus 360. Negative 135 plus 360 is? B. The dog outside is the corner of a rectangular garage. He is given enough leash to run along a 20-meter circular path. This is the what? That's the dog. Also, it is what? The arc length. Okay. He completes 3/4 of a circle. If he completes 3/4 of a circle, they actually gave us theta. What's a full circle? 4/4 of a circle. Yes. How many degrees is it around? 360. So you could go 360 times 3/4, or how much is it around in radians? Because that's what we need to fill into this formula. 2 pi times 3/4, which is 6 pi over 4, which is 3 pi over 2. Or hey, unit circle. 3/4 way around is 270 or 3 pi over 2. They gave it to us numerous ways. They want the radius, correct? They want the length of the dog's leash, which is the radius. Okay? So theta equals A over R equals A over theta. The hardest thing we need to remember here is that theta needs to be in radians, not degrees, right? We can't fall to that. So if we get our answer in theta, it's in radians. So if they ask for degrees, we have to convert at the end. Okay? Divided by 3 pi over 2, which is 20 times 2 over 3 pi, which is 40 over 3 pi, which is what? To the nearest 10, 4.2. Your diploma will seem awfully thick as well, but sometimes it only has one question per page, right? So it will look thick because they want to make sure you have enough room to work out your stuff. So a lot of people want extra space. You don't need extra space often, but they do have an extra piece of graph paper in the back that you can rip out, an extra piece of working paper, and your formula sheet. I often rip them out, tell people to rip them out so that you can do your unit circle. You're not going to run out of time to write your unit circle out properly. Let's just say you got enough. The unit circle is shown below. Oh, it's a unit circle. Unit circle gives us 3 ideas. It tells us x squared plus y squared equals 1. It tells us go to your unit circle. It tells us cos theta and sine theta, right? Those are the 3 things it tells us. So this one says the value in standard position point p, k, and negative or 0.6 is on the terminal arm. So what's k? K is negative because we're in this quadrant. Do you agree? On the unit circle, what's r? 1. We know it's x squared plus y squared equals 1. We know it's about the center of the circle. Okay, so we have k squared plus 0.6 squared equals 1. K squared equals 1 minus 0.6 squared. K equals what? Negative 0.8. Just so you know, you wouldn't even have to solve it in this case because they only have that answer and it's in that quadrant, so we know it's not these two. You did need it for the next one, but just proving that you could have narrowed it down to 2 even if you had no clue what you were doing, right? Just based on the graph. The exact value of secant theta. Secant goes with cos. Cos is cook extra rice, so this is rice extra. So it's going to be 1 over negative 0.8, which is which one? Negative 5 pi, negative 5 over 4, eh? What do you think the 5 over 3 is for? If you picked y instead of x. Okay. Ooh, we have the terminal arm at an angle 70 in standard position intersects the unit circle. They want to know x, y. They're telling you cosine, right? They're saying cos 70, same as that other question, sine 70. Cos of 70 is, they want it to 2 decimal places, 0.34. Sine 70 is 0.94. So my answer is 3494. That quick, that easy. We need to remember when it says on the unit circle, there's that third option that we could choose. Cos, sine, Calgary Stampede. Okay, if cosecant theta equals 2 over root 3, where 0 is less than or equal to 2 theta, then theta lies in quadrant what? It's sine positive, so it's quadrant 4, right? Because sine is positive or quadrant, and 2 or 1, so B and D are out, even if we have no clue what we're doing. So, it's resume your. So the catch is that our x could technically be both negative or positive, hence why they have that. Root 3 2, 2. So you're going to get x squared equals 2 squared minus root 3 squared. X squared equals 4 minus 3. X squared equals 1. X equals plus or minus root 1. X equals plus or minus 1. And they want cotan. Cotan is the opposite of tan. Tan, your x box. So x box, your. X is negative 1. Y is root 3. X is plus or minus 1, sorry. So it's C. This one's tricky. This one's hard. This one I knew a lot of people on my diploma when I saw this on the diploma when it was given, because this is from a past diploma that they released. I was like, eek. Okay. So we need to find the C value here. Okay? The C value happens on sign positive. So it's going to be where the midline goes through here, right? The midline correctly goes halfway through here and here. We agree? Okay, so I need to find out what the heck this is. All right? So what's the distance between negative pi over 6 and 5 pi over 6? What's the distance from here to here? 6 pi over 6, is it not? Pi over 6 plus 5 pi over 6. The distance is actually 6 pi over 6, which is pi. So half the distance is pi over 2. So half the distance from here to here is pi over 2. We agree? So if I just take this distance here and I subtract off pi over 2, I get where that happens. So 5 pi over 6 minus pi over 2, 5 pi over 6 minus 3 pi over 6. You get a common denominator, which is 2 pi over 6, which is pi over 6, which is a decimal. Yep, that's so not right. I just wrote the 6 again. Pi over 3, which is what? It's A. Last one. A local park with a radius of 195 meters. Sometimes we stretch stuff a little bit. Okay. Has a circular running trail surrounding it, as shown below. The shortest distance from the running trail to the parking lot. I actually think this one's a really nice drawing. Like the person did a pretty good drawing of it. Is shortest distance from the running trail to the parking lot is 5 meters. So from here to here. And they drew it so that you didn't have to guess, right? Like they don't, if it's not like perfectly understandable, they'll draw it for you so that you aren't like guessing what they mean by that. At a constant speed, Ellie can complete 4 laps around the park in 32 minutes. So how much minutes does it take her to complete 1 lap? So the period is 32 divided by 4, which is 8 minutes. Ellie's distance from the parking lot as she runs, S in meters, as a function of time t in minutes, can be represented by what? So from the parking lot. So the parking lot is what? It's technically 0. It's like an upside down Ferris wheel. So they want B and D. B is what? 2 pi divided by 8, which is pi over 4. Right? And what is D, guys? D is the center of this, correct? This shares the same points. Where is the center at? 200, because it said from the parking lot. Okay? Remember, you have all those review questions in your textbook.